Okay, so good evening, everyone. So here we will discuss the tutorial, or we can say some sample question paper for the week 9 content. So that will definitely help you to solve the questions related to the week 9 content, which contain the free vibration or the damped vibration of the multi-degree of freedom system. So in this we will solve 4 to 5 problems, similar kind of nature, so that we will find out some model frequencies, mode shape, and then using those things we will find out that. Response, like the free vibration response, what is the free vibration response of that. And in this only, the up to the, it is restricted to the free vibration response. The week 10 content that would be cover the force vibration response content. So let me share my screen so that. Yes, so let us discuss first your doubt. What was your doubt? So week 8, question number 1. Okay, so what was that? Can you tell me that question? Like there was one spring or some damper, it connected to the mass, then a damper was there, then a mass, that was m or 2m. What was that? Can you help me to get the question?
Yes, yes, correct. What they are asking equation of motion regarding the
Yes,
x1 and x2.
so that would be your x1, that is
Yes,
your x2, and the stiffness is k, c, and c. That was the same question.
yes, yes, yes.
Okay, so let us suppose we consider like my x1 is greater than x2. Okay, so what are the forces will apply on that my case? That is the one with the k time x1, c time x1 dot. Okay, and then if my x1 is greater than this, so that force is also applied into this direction, c time x1 dot minus x2 dot. Okay, if if I consider x2 minus x2 greater than x1 in this case, how my force would be like that? These are same, k time x1, c time x1 dot, and then this direction would be the like c time x x2 dot minus x1 dot, this way. Is it clear up to this?
There we don't have. Yes, yes. Okay.
Like only the sign convention will change. If that will be reversed, then your sign convention here will be changed. So now if you make the equation of motion, I don't think you will be having doubt for the mass 2 or the block 2, what will be the forces for either. If you take any one of them, if you take this one, so it would be your cx2 dot minus x1. Okay, or either if you take this one, previous one, that force would be applied like this one, and your force would be the c x1 dot minus x2 dot. But whichever you will take, that will give you the same answer. So mx2 double dot. So your equation for the second block would be the mx2 double dot plus c into x2 dot minus x1 dot is equal to 0. That will be your equation. I think that was the C equation, C answer. Only mistake was there that there was some error. So that was the x1 in the C option. Is it correct?
Yes, yes. What I did mistake is the first diagram what you have drawn. Uh, the upward force C into x1 dot minus x2 dot is there, right?
Yes, this one. Yes,
First diagram, first free body diagram.
yes.
What I did is same in the same direction. C into x2 dot minus x1 dot I have taken.
No, no, no. That would be wrong.
Okay, okay. Got
Because if you don't like, you do not remember to those things. Like
it. Okay.
firstly, like think like my x1 is more than x2. Okay, so what is the relative displacement will taken care by the c is the x2 minus x1. Okay, so that will deform that one, like my x, like how much that will deform x1 minus x2. So how much resisting force that will you apply in that opposite direction, that will be the c time x1 dot minus x2 dot. This way you can do.
Okay.
So that's why I was like, I was thinking to put it on the, like the right on the, like take a note and then sending it to you online, but I was thinking to discuss in the live session to do better for others also.
I have answered the two options actually, which was correct answer and with the wrong answer also.
Okay,
It
so
is
you give the option A on option D.
yes, sir. Both answers I have given.
Yeah, but that was the cancelled out, I think, C option. So only
Uh,
A option will be keep an as a correct answer, I think.
yes, yes. Can you compensate that?
So did
Actually,
you get the mark for that?
yeah, yeah. Actually, I also up the first answer. First answer.
You got the half marks, no?
Yeah. I have to get half marks.
Okay, so that's okay. Anyway, that you will get only the half mark if you will do that. Otherwise, if you pick the C, you will get the full mark, I think. But it is not in my hand actually. I can ask them, like we have to ask the NPTL. They have revised that only the final because of discrepancy in the option C, so they change it to one only A. So I think they will update that. I think that answer will be updated.
Okay.
Your marks will be updated. I think it is not updated now. Is it
Yeah.
updated?
Till now, I didn't get updated.
They will update it. Like they have posted on that like the news section, like information section, that their option will be A. So they will update it soon.
Okay.
Okay, let us start for the week this week. So we have the first like a question which we need to find out the which one is the correct option between two modes. One is the nth mode and another is the rth mode in a multi degree of freedom system. So using like we have the given the four options. So can you tell me which options are correct for the given situation? Initial force, like these options are: initial force in the nth mode do not do any work in the going through the rth mode of displacement. Orthogonality condition for the two mode is satisfied only if omega n is not is equal to omega r. Orthogonality condition for the two mode is satisfied only and if each mode shape is normalized with respect to the largest degree of freedom displacement, and D is the none of the above. So can you tell me which options are correct? Anything? Let us discuss. First, let us discuss about the option A. So if let us consider for the nth mode. So in the nth mode, what is my displacement? U and T would be the Q and T time phi n. Okay. So the corresponding acceleration would be the U double dot n T is equal to Q n double dot T time phi n. So the inertial force, what will the inertial force this? Fi into nth mode, that would be the m or minus m time U double dot n T is the inertial force in the nth mode. So if I will put this value into this, so that will be the minus m q n double dot T phi n, that is the my force. Now let us consider in rth mode what will be my displacement, that would be urt time qrt time phi r. Okay, so find out the work done from this to this. So for the work done from nth mode to rth mode, we multiply this simply. So if we do this, we will find out m q n double dot t phi n qr. So we need, there is some matrix terms, okay, so we need to do this into the matrix form. So t qr t time pi r. So if we rearrange the terms, we will get m, we will get it phi and t, m time phi r into q and double dot t into qrt. Okay, so this would be what, because my nth and rth mod are different, so due to orthogonal, what will be this, can you tell me? So if you go through the orthogonality conditions, phi 1 transpose time phi 2 would be 0. So here we have the nth and rth mode. So phi and t m time phi r would be 0. So the work done from this fi n from the nth mode to the rth mode is coming out to be 0. Okay, so this option A is correct. Now come to the question 2, or like option B. Can you tell me like orthogonality, when the orthogonality will be satisfied? So in option B, my orthogonality for two modes is satisfy only if omega n is equal to omega r. Okay, so my orthogonality will be satisfied only when my two modes are different mode, nth and the rth mode. Okay, at that time it will be satisfied. So option B is wrong. Like option A is okay, option B is not okay. Now let us discuss about the option C. The option C is that orthogonality condition for the two mode is satisfied only if the mode shape is normalized with respect to the largest degree of freedom. So do you know how to the normalization of the mode? Let us suppose I have the modes like phi is equal to some 4 5 4, some 2 3. Okay, so if I find out this phi 1 t m time phi using this one, it should be 0. And if I normalize this mode with respect to, let us suppose, with the topest one or the largest degree of freedom, so if I will normalize with this, how much it would be? 1 and 4 by 5. And for this, if I do this, that would be, let us, we are normalizing with this, so that would be uh, 2 by 3, and that would be 1. So if I will get using this 5 and t m 5, that will also come out to be 0. So my orthogonality, not mine, it is orthogonality. Okay, so orthogonality is independent from the normalization of the mode. So option C is also wrong, because that is anyway it is okay, because if you will do, then it will be satisfied, but it is not like every time it is not, and none of the above is not like. So option A is your correct answer. So any doubt in this question? Should we move to further? Anyone? If not, let us move to the next question. So in the next question, we have given a two story. One, two, masses are lumped, 2m. What is that? FTFF, what you are writing? Any doubt is there? If not, okay. So if we have a two-story system, one and two, so the masses are lumped are masses are 2m and the m. So any displacement vector u can be represented by a set of n independent vector using the mode shape and the model coordinate. Model coordinate or the model expansion. So the displacement is represented as u is equal to phi times q. So a two-story shear frame is shown in the figure. Mass in the stiffness are also noted. So determine the modal expansion factor Q1 and Q2 of the displacement vector using initial condition or the using that U is equal to your 1 1. Meaning means if let us suppose I if I lumped it like that, okay, some 2m stiffness K 2K. So my displacement of this will be like that 1 1. So how I can divide it into the model expansion factor? So like it will deflect in which manner? Plus because we have the two mode shape, so we need to find out the q1 and q2. So do you know how to find out the model expansion? If you go through the content of the week 9, sir has discussed how to find out the model expansion factor. So that is given as a qn is equal to phi n transpose time mass matrix time u divided by phi n transpose mass matrix time phi n. Okay, so first we need to find out the mass matrix. Okay, so the mass matrix is simple. This is 2m, this is m. So the mass matrix would be 2m 0 0 m. U is given to you as 111. So first find out the q1. So q1 is phi 1 transpose mass matrix u divided with the phi 1 transpose mass matrix phi 1. So can you get me this? Phi 1 is what? You have given the mod shape also. Mod shape is given to you this 1 by 2, 1 minus 1, 1. This is the mod shape you have given. So phi 1, let us put the phi 1. So how much it would be? Phi 1 transpose. So that would be 1 by 2, 1. Mass matrix would be 2m 0 0 m. U is given to you 1 1. Again this one 1 by 2, 1 2m 0 0 m 1 1. So can you get me the value of this q1? And using the same, can you get me the value of the q2 also? Please give a try to find out the model expansion for this q1 and q2. Anyone? It is simple. Just put the value in the calculator, take the m outside, that will be cancel out up, and then it would be simple. Very simple calculation. Because now in the multi-degree of freedom system, you need to deal with the these kind of matrices and the formulations, calculations for the 2 by 2, 3 by 3. I think most maximum can be go with the 3 by 3. For the higher, we have to use the MATLAB. But in this course, we are limited up to the 3 by 3.
It's getting one.
No, sorry, that should be 1 by 2, 5 1. That should be 1 by 2 because 5 1 is there. And similarly, you can find out the Q2 also. That is the phi 2 minus 1 1 2m 0 0 m 1 1, then minus 1 1 2m 0 0 m minus 1 1. So if you solve this, I am getting it as a 4 by 3 and minus 1 by 3. Any doubt? So that you can check like u is equal to should be phi 1 q2 q1 plus phi 2 q2. So you can check whether like u is what 1 1 1. So phi 1 is what? Phi 1 is 1 by 2 1. So your q1 is the 4 by 3 plus phi 2 is minus 1 1 multiply with the 1 by 3. So if you solve this, you will be getting this 2 by 3 and 4 by 3. Okay, and then if you do this minus 1 by 3, and that would be the 1 by 3. Not this would be plus, this would be minus, because it is a minus 1 by 3. So if you sum it up, it will be coming out to be 1. 2 by 3 plus 1 by 3 1. 4 by 3 minus 1 by 3, it would be 1. So this is our model expansion. Like how that will be, like if you give the initial displacement like that 1 1, how my modes, how my structure will deflect in each mode, and is at each degree of freedom. So using that you can find out the model expansion. Okay, so let us move to the next question. In this question we have the two question actually, same nature. So we will discuss only one question, this one, because they have the same kind of nature. Because two question covering is like very it will take very high time. So we are not solving this, we are solving this only. Okay, later if you want you can solve it by yourself, and for this I will upload the material regarding this to solve this question. So for this we have given a three-story building. First, we need to determine the natural frequencies and the mode shapes, and x, like these would be because we don't have the values of the m and ei and the length. So that would be in terms of the obviously m, ei, and h. And we find out the mode shape and identify the associate natural frequency with particular mode shapes. Verify the mode shapes that satisfy the orthogonal properties, and normalize each mode so that the model mass mn has the unit value. We have to normalize our mode shape like that. When we calculate the mn generalized mass, we call it as a mn. So when you calculate mn like in this, so mn would be, mn is phi n t time mass matrix time phi n. So that should be 1. So we need to normalize our mode shapes like that, so it should come out to be 1. Okay, so first we need to develop the mass matrix, stiffness matrix, and then we need to find out what are the model frequencies for that. So let us do, can you develop a mass matrix for this or a stiffness matrix, both them? So please try to develop in terms of the ei, it would be, and it is easier for you because the stiffness in the each and every building is the same, ei. So we have the 12 ei by l cube for the each column, so that you can consider as a k. So from that you can calculate it. So please give a try. give a 5 minutes so that we will discuss later. So you can give a try for that, like development of the mass matrix. All the degree of freedoms are 1, 2, 3. This is 1, 2, 3. So the let me simplify this. So stiffness for this is for the 12 EI by H cube. So that is the same for this. So if I consider this K, that would be K for this K. So let me simplify this for you. I have the mass, which is our M, M, 2M, stiffness is 2K, 2K, and 2K, and degree of freedom is 1, 2, 3.
Mass is m by 2, right?
Yes,
Now,
that is yes, that is M by 2. So find out, anyone with the stiffness matrix.
would be 6K.
You are getting 6K.
No, no, matrix K11.
What is the K11? Is it the 6K or 4K? Like, if you, as you know that method, if you apply, if you apply a load here, that will deflect like this. So how much force it would be?
Okay, okay.
2K, 2K. So how much K11 would be? 2K plus 2K, 4K. Okay. What is the K21? Not that K21, K12. So K12 would be minus 2K, or K13 would be 0. Similarly, if I apply here initial displacement, like shape doesn't matter because we are only finding out the forces. So that will be also 2K, 2K. So that is the K22. So K22 would be 4K, and at this point, that is the K12, which is minus 2K, and at this point minus K32, which would be also minus 2K. Okay. Now similarly for the last one, if I apply the unit, this will come like this. So only 2K is there. So that K33 is 2K, and this would be K23 K13. So K13 would be 0 and K23 is minus 2K. Yes. So that would be also in this side. Like that. Do you understand how do we calculated it?
Yes, yes, understood.
And not confusing the sign conventions. It is a sheer kind of things. Sometimes you might get confused. So let me write it like that so that no one would confuse it. Okay. So my stiffness matrix would be K is equal to 4K, 2K, 0, 2K, 4K, minus 2K, 0, minus 2K, 2K. So we will calculate in terms of the K. So that will be simpler for us. That is the 4 minus 2, 0, minus 2, 4, minus 2, 0, minus 2, 2. Okay. Now you have the mass matrix. So mass matrix is the simple. There's nothing to do with it. That is that is the M 0, 0, M 0, 0, 0.5 M. Okay. So you can perform the I can you can find out the eigenvalue and vector. So eigenvalue and vector. So that would be k minus lambda m is equal to 0. Okay, that would be the mode like this. So if I put this into the, that is coming out to be 4k minus lambda m minus 2k 0 minus 2k 4k minus lambda m minus 2k 0 minus 2k, and then it is 2k minus lambda m by 2. That should be 0. So you can eliminate the lambda. Last time we have discussed. Okay. So if for the sake, if you want to eliminate this, you can simply write this 4 minus lambda minus 2 0 minus 2 4 minus lambda minus 2 0 minus 2 2 minus zero point 0.5 lambda. Okay. And if you find out the determinant of this the equation, that will be coming out to zero point 0.5 m cube lambda cube, or if you will keep the lambda also, that will coming to be same. If I will remove the lambda, if you, yes, if you will remove this, you will get zero point 0.5 lambda cube plus 6 lambda square minus 18 lambda plus 8 is equal to 0. So if you solve this, you will get lambda 1 is equal to 0.535. So that factor will come into picture, k by m. Lambda 2 comes out to 4 k by m. Lambda 3 will comes out to be 7.464 k by m. So as you know, you have the k is equal to 12 ei by h cube. So you can find out the omega 1 because they are asking your omega in terms of the mass and the elastic modulus E and the moment of inertia I. So put this into the omega 1 will be the lambda 1 square root of this. So can you find out this? What is this? Let me write it. So 2.53 EI by mh cube. Similarly, can you find out the omega 2 and omega 3? Omega 2, omega 3. Please find out the omega 2 and omega 3 in terms of the EI, M, and H. And after that, we need to find out the mode shapes. Anyone with the omega 2 and omega 3? So that we are getting it is omega 2 as a 6.6.928 or 93, you can write it, EI by mh cube, and that will be the 9.464 EI by mh cube. Okay, now we need to find out the mode shapes. Mode shapes. So can you find out the mode shapes? For lambda 1 is equal to 0.535 k by m, or you can directly put uh, instead of the k and m, you can directly put the what is the coefficient you are getting for the lambda. So in that equation, that is the 4 minus 0.535 minus 2 0 minus 2 4 minus 0.535 minus 2 0 minus 2 2 minus zero point 0.5 times 0.535. So if you solve this, you will get the 511, 512, 513, which is 21. 511, 521, 531 is equal to 0. So the matrix is coming out to be, after solving, 3.466 minus 2 0 minus 2 3.46 4 minus 2 0 minus 2 1.732 511 521 531. Can you get the mod shape for this value of this? Take any equation and give me the mod shape. Anything. What is the value? And let us normalize it with the 531. Like we are normalizing, like consider that 531 is the one. So using that, can you give me the 521 and 511? Anyone? Anyone? Not? Let us calculate. So let me consider the first equation, not the first. First, let us consider this one. So in this, if I consider this one, minus 2, 521 plus 1.732531 is equal to 0, and as we have considered 531 is equal to 1, so what would be my 521? That would be the 1.732, simple, or something else, divided by 2, so that would be coming out to be 0.866. Similarly, I get the 521, so now you can take this equation, first equation, 3.466.
So there is a numerical error, 1.723 now. It's 1.732. Just to check the two
Okay,
lines. Subs.
732. Okay, that would be 732, but the final answer is okay. Is it okay?
Okay, sir.
Okay. So 3.446466 minus 2 times 521 is equal to 0. Now put the 5, like we have the value of the 521, so put it as a 0.866. So you will get the 511 as a zero point 0.5. Okay. So here your mode shape for the 5 1 vector is coming out to be zero point 0.5, 0.866 and 1. Similarly, you need to find out for the lambda 2 is equal to, or the omega 2, which is 4 into k by m. Okay, so that you can do easily. So I am writing the final matrix directly. So that is 0, minus 2, 0, minus 2, 0, minus 2, 0, minus 2, 0. That is 512, 522, 532, 0. So can you give me the mode shape for this? Considering again 532 as a 1, this would be very simple, I think. I think this is a very simple. So from this first and second equation, what I am getting, my 522 would be 0, and from this equation, third equation, minus 2, 512, minus ka 2, 532 is equal to 0. If this is 1, what will be my 512? That will be minus 1. So my 52 is it minus 101. Okay, and similarly for the third mode shape, you can find out for lambda 3 is equal to 7.464 k by m. I'm writing the simple mode, or like let me write the simple equations. 3.464 minus 2, 0, minus 2, 3.464 minus 2, 0, minus 2, 1.732, 513, 523, 533 is equal to 0, 0, 0. And if you will solve this, your 53 will coming out to be zero point 0.5 minus 0.8661. Okay, so the my mod shape, overall mod shape 5 matrix is coming like this: zero point 0.5 0.8661 minus 101, 0.5 minus 0.866 and 1. So can you draw these mod shapes? It is very easy. You can. So now you can draw the mod shape how your mod will be look like. So let us take the 5 one. So in that case, we will take only the like the simple, or do we take that whole model? So that my structure will deflect like this. So that is how much? That is 1. Okay, that is 0.866, and that would be the point 0.5. Okay, now corresponding to phi 2. So in that, like my third mode is the negative, second mode is 0. Okay, and the first mode is negative. So that would be like that. Okay, then what is that? My first mode is 0, so that will go like this, and that is 1 this way. So that is 1, minus 1, 0. Okay, now for the third mode, that will be the same. These things you can draw. If you have any doubt, you can ask me here. Like in the first mode there is no crossing, in the second mode we have the one crossing, in the third mode we will be having two crossings. Do you know these things? So in this first one is the point 0.5, second one is the 0.86, and then third one is the 1.866 negative, and that is point 0.5. Okay, these are mod shapes. Now using these mod shapes, we need to check the orthogonality, whether my structures are satisfying with orthogonality, whether it is satisfying or not. So can you give a try for the orthogonality? So now we have the part B, in which We need to check the orthogonality. So how do we satisfy the or define the orthogonality for the both mass matrix as well as the for the stiffness? So if y, as we have discussed in the first question also, phi r t m time phi n should be 0. For the stiffness also, phi r t k time phi n should be 0. Okay. So we will do one or two example, one or two, or we can do six, all sixes. So let us do for the mass, phi 1 transpose mass time phi 2. One you need to do this. Another you need to do with the phi 1 t mass time phi 3. Okay. Another then you need to do phi 2 mass time phi 3. Okay. Then this for the mass matrix. Then phi 1 k time phi 2, phi phi 1 t transpose k time phi 3, and phi 2 transpose time phi 3. So you need to do this. So what is phi 1? Phi 1 transpose we need to take. So phi 1 transpose is what? 0.5, 0.866, 1. Mass matrix is your m m 0 0 0 m 0 0 0.5 m, and phi 2 is your minus 101. So can you calculate this? Can you try and calculate this? What are those things are coming? Anyone with the no, orthogonality? Like what will be this value? Similarly,
Zero.
okay, you calculating this or you are knowing that it should be satisfied. So
No,
it
no, no. I have calculation.
okay, okay, no problem. Similarly, you can do this one same mass matrix, and then it would be uh, phi 3 is how much? That is zero point 0.5 minus 0.866, 1. That will coming out to be 0. Similarly, you can do this minus 101, same matrix, mass matrix, and then some phi 3 is zero point 0.5, 0.866, 1 is perfect. Similarly, you can do for the like all things, your K matrix would be there, and then you are getting. So here you can make a statement that it is satisfying my phi 1. Let me write it so that someone will not confuse. So my these that like the orthogonality condition is satisfied. Now come to the third part, which is we need to calculate normalization of the mode. So in the question itself given us, like my mn should be 1. Okay, so first I will calculate what is coming. So first calculate m1, which is phi1 transpose mass matrix phi1. So if you put the phi1 transpose, it is how much it is. It would be zero point 0.5, 0.8661 mass matrix m 0 m 0 0 point 0.5 m, and then this phi 1 is same 0.5, 0.8661. So can you get me the value of m1, m1, m2, m3? Same kind of thing would be there for m1. For m2, that would be the phi 2 transpose m phi 2. So get me the m2 value. That would be our vector is m2 is what? It is minus 1 0 1. Then you have the mass matrix m 0 0 0 m 0 0 0 point 0.5 m, and then it is minus 1 0 1. So calculate it also m2. Then m3, it is phi 3 transpose m time phi 3. So how, what is my phi 3? It is zero point 0.5 minus 0.8661. That would be m 0 0 0 m 0 0 point 0.5 m is zero point 0.5 minus 0.8661. So get me this, all three values. Anyone with the values?
M1 is 1.5
Okay.
M.
Yes, that is okay. That is right.
It is also 1.5.
Okay.
Second M2.
Yes, it is right. So it is a 1.5 m. This is also 1.5 m, and that would be also 1.5 m. Okay. So in this, we have they have called us that mn should be like m1, m2, m3 should be 1. Okay. So for m1 should be 1, what I need to do, like in initially it is coming out to 1.5 m. So if I divide my mode shift phi 1, divide it by the square root of 1.5 m phi 1, I will get it. Like m1 is this, so if divide it by the square root of 1.5 n, so let us suppose phi 1 is giving like me this, divide it by the 1 over 1.5 m point 0.5, 0.8661. So can you get me this phi 1? Similar kind of thing would be happen for the phi 2 and phi 3, because we have the same. If the m2 would be, let us suppose that would be 3m, then we need to divide the phi 2 with the square root of 3m. Same kind of thing, if my m3 would be the 5, then we need to divide it by the square root of 5m.
Sir, actually, I'm not getting here. What M1?
Like
1.5. I'm
like
not getting. Can you please tell me again?
like my m1 is coming out to be 1.5m. Okay. So what is my m1? Is that phi 1t mass matrix time phi 1. It is giving the 1.5 m. So if I divide it by this is as a 1.5 m, and this is also 1.5 m, like
Okay.
5 1. So that
Okay.
will give me the 1 at the end.
Yes. Yes. Yes.
So that thing
Okay.
I. So in this case, what is over all these mn is coming same, 1.5, 1.5, 1.5. If let us suppose a scenario where we have the one is mn is the m1 is the one like 1.5, m2 is the 3 3m, m3 is the 5m. So in that case, in the each cases, like for the first case phi 1, we need to divide the square root of 1.5m. In the second case, we need to divide it by the square root of the 3m. The third case or the third mode, we need to divide it by the square root of the 5m. It's just, so it will coming out to be then 1. Okay, so divide it this one. Same kind of thing is for the -1 0 1, and for phi 3. So can you get me the value? Like take outside square root m.
Uh, can you again explain this? Suppose M1, M2, M3 are not equal.
Yes,
In that case, can you please explain once?
yes. Let us suppose my m1 is 1.5m, m2 is 3m, m3 is the 5m. Okay, so in that case, for the phi 1, I will divide it by the square root of 1.5m. Okay, in that case phi 2, for phi 2 I will divide it by the 3m.
Okay, okay, understood. Okay.
This way.
Yes, thank you. Thank
If m1, m2, so get me the values of phi 1, phi 2, phi 3 after the normalization.
you. It was 0.40851.
Let me check. Yes, it is coming out to be 0.408,
0.707,
707,
0.8164,
816. Similarly, this we can write it as a,
0.8164.
okay. Is there any doubt in this question, or should we move to the next one? If no, let us move to the next question. So in this question, we need to determine the free vibration response of the same structure, same problem, whatever we consider in this, like the previous, like the mode shape and all that we have the, like I will provide you. So we need to find out the free vibration response. So what we got this omega 1, omega 2, omega 3. Using that, you can do that. So like omega 1 is given as a we have calculated 2.536 EI by mh cube. Omega 2 would be 6.9282 EI by mh cube. Omega 3 is 9.4641 EI by mh cube. And phi we have calculated in the previous question, point 0.5, 0.8661 minus 101, point 0.5, 0.8661. So please try to get the free vibration response, because if you have read in the class, then you can go with that, you can find it easily. So do you know the procedure how to find out the free vibration response? Like, as that has been discussed in the week 9 content as well. So did you remember this, or we need to discuss it?
Discussing will be better, sir, if something.
Okay. So in the multi degree of freedom system, our response ut for the free vibration is given as from n is equal to 1 to, like, we have the three mode shifts, that would be the phi n time qn 0 cos omega and t plus qn dot 0 by omega n into sine omega and t. This is, so this is the ut. This is a simple this is a simple expression for the STO system we have used for the STOF. So we have divided into the, for the, if we have, as we have the number of mode multi degree of freedom, we have the three degree of freedom system. So the qn is the model expansion factor, which model expansion, so that we have calculated in the second question. So for the each mode shape, each mode you have the q1, q2, q3, q1 dot 0, q2 dot 0, q2, q3 dot 0 is there, pi n is there. So using those things we can determine. So you have given the initial condition, you have given the u is equal to 1, 2, 3, and u dot 0 is not given, so it would be 0, 0, 0. Okay. So can you give me the q1 0, q2 0? How do we find out the q1?
Phi 1 transpose M
Yes.
U of 0
And then,
by phi 1 transpose M phi 1.
yes, nice. So for the generalized term, the q1 is the, that would be the phi n transpose mass matrix u0 phi n t m time phi n. Similarly, we can find out the q and dot. Okay, just for the initial q and dot 0. So that would be the similarly phi n t m u dot 0 divided by the phi n t m phi n. So let us find out the q10. We have the phi 1, we have the m, you have the u. So give it to me the phi 1, the q10. So that phi 1 is that point 0.5, 0.8661. Okay, mass matrix, we have the m 0, 0, 0, m 0. 0.5 m, and that is 123 divided by the phi and t m. Phi and what would be the 1.5 m? We have used that, so I can directly, can I write it as a 1.5 m?
Yes.
So similarly, find out the q20 minus 1 0 1 m 0 m 0.5 m 123. That would be also same 1.5 m. Similarly, q30, that would be the zero point 0.5 minus 0.866 1 time m 0 m 0.5 m time 123 divided by the 1.5 m. So can you give me the values? Solve this.
That initial displacements are corresponding to DOF, right?
Yes, yes,
From
yes.
top to bottom.
Yeah, bottom to top, not the top to bottom.
Okay, okay, bottom to top.
Because in that question, if you look into this, these are the one, two, three. One, two, three from what? Top to bottom. Degree of freedom one,
2, 3.
one, two, three. So those are given from bottom to top. So one is at the first degree of freedom, two is at second, three at that. Use that. हेलो. अरे मेरा लेक्चर है 8 बजे तक, मीटिंग चालू हो गया क्या? अच्छा. ये पहले से शेड्यूल दिया, आज अचानक हुई है? अच्छा अच्छा, ठीक है. हाँ ठीक है, ठीक है. हाँ हाँ, ठीक है. So anyone with the Q1, Q2, Q3?
In the first case, 2.488,
Okay, in the first case we are getting 2.48,
0.333,
0.33.
0.178.
Okay. And what would be the my Q1 dash 0, Q2 dash 0, and Q3 dash 0? Can you can you give it to me directly?
0.
That would be 0 because our initial displacement of is given to S0. Initial velocity is given to S0. So now you can calculate your U1. What was that your UT? That was the summation of n is equal to 1 to 3 phi n qn 0 cos omega n t plus qn dot 0 omega n sin omega n t. So put this into the model code, like u1, u2, u3. So for the first mod phi n, it is what, zero point 0.5, 0.866, 1, time q10 is what? Q10 is 2.48 q10 cos omega 1t. Okay, and that the qn dot is 0, so that term becomes 0. Similarly, for the second mode, it would be minus 1 0 1 times 0.33 into cos omega 2t. Keep in mind it will be 2. In this it will be 1. Okay, because these things will matter if you plot. Like here I'm not plotting this. Once if you need you can plot it, so keep in mind those frequency values. Zero point 0.5, 0.866, 1, 0.1786 cos omega 3t. So if after rearranging the terms or simplification, it is coming like this: 1.24, 2.15, 2.448, 488. Okay, cos omega 1t as this minus 0.330, 0.33 cos omega 2t plus 0.0893 minus 0.154, 0.178 cos omega 3t. So this is your u1, u2, u3. And it out in this question. Now, then the next question do we have, like same problem with considering the damping, because I'm using the same problem because you do not need to find the m and k again. So that's why I extended the same problem with that. So it will be useful to you, like the full problem with the finding out the mode shape to frequency to the orthogonality normalization, then the free vibration, then the damped vibration. So that is covered through the one problem only. So can you because you know the solution for the damped vibration, it's the same solution, only term would be there omega d, except of the omega, and that would be the omega d, and that solution will multiply with the e exponential term e raised to power minus psi omega n t. So the solution for this damped vibration is given as a ut 1 2 3 phi n e raised to power minus psi omega n t q10 cos omega d t for the nth, and nd I'm writing nd, and for the mode shape q1 dot 0 by omega d sine omega and d t. Okay, so what is my omega and d? It would be omega n time 1 minus chi square. So you can calculate it. So you can find out the, we have the omega 1 omega 2.
I think we have another term in the q qn dot 0 plus xi n omega n qn of t will be
That
there.
is yeah, that would be there, but the damping is small for the 5% damping. If you have the damping is higher, then it would be some 1 minus xi square, that is we are neglecting, or that would be there if we have write it omega n, that term would be there like omega n 1 minus xi square. I think that term would be there at that.
No, no, no. I'm telling you. In the first, you can see U of t equal to sigma xi n e power minus xi omega nt in bracket qn dot 0 cos omega dt plus qn dot 0 in the numerator only plus xi n omega n.
Yes, yes, that I missed actually. Missed. So that term would be qn dot 0 plus xi n omega n qn 0. Is it you are asking?
Yes, yes,
So that term would be there. Okay. Thank you for pointing out. So you have the omega and d. So omega n I can write for you again 2.536 EI by mhq omega 1. Omega 2 is for you is the 6.9282 EI by mh cube, and omega 3 would be 9.641 time EI by mh cube. So using this, you can calculate the omega 1d, omega 2d, omega 3d. Okay, find out that. And same, we need one term also, xi 1 omega n. So xi n omega n, you can find out omega n. You have xi n is 5% for the all the modes. So you can find out xi 1 omega 1, xi 2 omega 2, xi 3 omega 3. So find out those terms. After finding out that, there is nothing to do. We need to put those value into this only, because we have find out the q1, q1 0, q2 0, q3 0 in the last problem, and qn dot would be 0. So please find out values. I am coming back in the 1 minute. Anyone with the answers? If not, let me write it. So your omega 1 t would be what? So uh, we have this coefficient, and how much that would be 1 minus xi square. If I will put 5% damping for the all the modes we have, so how much it would be? 1 minus xi square. Let me calculate. That would be 0.998. So if you do 1 minus square, that is a 0.998. And if you multiply this with all of them, you will be getting 2.53727 EI by mh cube. For omega 2d, you will be getting it as a 6.9195 EI by mh cube, 9.4523 EI by mh cube. Okay. Similarly, find out this xi 1, omega 1, xi 2, omega 2. So xi 1 is the 0.05, and the omega 1 we need to do multiplication. So that will be 0.05 into omega 1 is what? 2.536 EI by mh cube. So if you do this, the final value is coming out to be 0.1268 EI by mh cube. So similarly, for this omega 2, for omega 3, you will be getting this 0.3461 AI by mh cube, and that is 0.4732 AI by mh cube. Okay, now you have all the values. So as your uh, q dot t is 0, q1 dot 0 for all the cases. So your ut will become from n to 3 phi n xi n omega n t time qn 0 cos omega n t and dt plus xi n omega n qn 0 by omega n d sin omega n dt. Okay, so get it one by one. So phi 1 is what? uh, Phi 1 we have what? Let me check. That was point 0.5, 0.8661 e raised to power minus 0.05 omega 1, we will keep it 1 t time q1, what we calculate? 2.48 cos omega 1 t plus xi n 0.05 into into omega n into q0 is what? 2.48, and omega n, yeah, how, what can I written? Omega n 1 minus 0.05 square. So omega 1 will be cancel out, sine omega n t. Is it okay if I write this?
Yes.
So if you simplify this, then you will get it. Okay, for the second mode, let me write it. For the second mode, minus 101 e raised to power minus 0.05 omega 1 t times How much was that value? 0.33. 0.33 cos omega 1t plus 0.05 omega 2 into 0.33 by omega 2 1 minus 0.05 square into sine omega 2t. Similarly, for the third mode, what was that? Zero point 0.5 minus 0.866 1 time e raised to power 0.05 omega 2 3t. Okay, that will be t, and that is the 0.178 cos omega 3t plus 0.05 omega 3 0.178 sine omega 3t. So if you simplify this, I can write the final answer. So that would be, you can do it later, 1.24, 2.15, 2.48 into e raised to power minus, let us keep it as xi 1 or xi because same, it is same omega 1 t cos omega 1, okay, or that will be the damp, no, omega 1 d, omega 2 d, omega 3 d. So omega 1 d t plus 0.0623 0.17107.124 e raised to power minus xi 1 omega 1 t sine omega 1 dt. Okay. Similarly, for the second mode shape, that would be the 0.33, 0.33 e raised to power xi omega 2 n, okay, into cos omega 2 dt plus minus 0.0167 0.0167 e raised to power minus xi 2 omega 2 t sine omega 2 dt plus 0.089.145.178 e raised to power minus xi 3 omega 3 t cos omega 3 dt plus the last one is that 0.0045 0.007 and 0.0089 minus xi 3 omega 3 t sine omega 3 d t. Is it okay? Is there any doubt in this? So for this problem, you can do one thing. This kind of problem, like to understand the behavior of that, how my mode shapes and are behaving, you can take any value of the m, k, h damping you have given. You need only m and k value, and using that, if you plot, you will be like learn a lot of things like how my mode shapes are behaving. If you plot this, how my response is looking like that. So we will be having the next problem. This is the final problem actually, because the last problem is that that won't be happen, and that is the same kind of problem in your assignment. So you can do, because that is the same as per the we have discussed in the current same kind of problem. So in this system, for a system shown in the figure, we need to find out the natural variable frequency in the mode shape, express the frequency in term of the MEI add, and sketch the mode shape. One thing, you need to sketch up the mode, and the structure is pulled through a lateral displacement of this. So you have given the initial displacement u1, u2, u3 is equal to 100. So we need to determine the free vibration response. This is the same kind of problem, only the behavior wise, like that was the simple day structure, this is the umbrella type of day structure. So because to develop a stiffness matrix, it is a it developed through the flexibility matrix, and then we need to convert it. So in this question we provided you the flexibility stiffness matrix in the mass matrix. Using that you can find out the mode shapes, and then you can find out the free vibration response. So can you give a try and to find out the mode shapes? Give a try to find out the mode shapes. Like you have the mass matrix, you have the stiffness matrix. That I don't think it will take time. So for this calculation, uh, you can consider this as a k dash or something else factor. So that would be easier. K dash or the k, I think. So your mode shape would be k minus lambda m is equal to 0. That would be the k is what? Uh, 28 minus 5 lambda, 6 minus 6, 6, 7 minus lambda, 3 minus 6, 3, 7 minus lambda. Do is equal to 0, and make a equation. Can you make the determinant equation using this? And then whatever the lambda you will find, the omega 1 is the lambda, and that is the multi factor of this also, 3 ei by 10 l cube, and m also, ml cube. So give me the equation for this characteristic equation for this, so that we can do that. So the characteristic equation for this would be the 5 lambda cube minus 98 lambda square plus 520 lambda minus 400 is equal to 0. Okay, and if you will solve this, you will be finding out the lambda 1 is equal to 0.9219, lambda 2 would be the 8.60678, and lambda 3 would be 10. So your omega 1 would be 0.5259 into ei by ml cube for omega 2, that would be 1.6135 time ei by ml cube, and then omega 3 would be 1.7321 ei by ml cube. So using this, can you find out the mode shapes? Please give a try to find out the mode shapes. Then after the finding out the mode shapes, in this question there is nothing. You have the initial displacement, velocity is 0. You need to find out the q1, q2, q3, q1 dot, q2 dot, q2 dot 3, and ut would be there. Anyone with the answer? Like what would be your mode shape? Am I audible to all of you? Is it clear?
Yes, sir.
Okay, so let us discuss the mode shapes. So if you will use this, so I will not spend time into the calculation, so that you can do by yourself using those thing lambda 1, lambda 2, lambda 3. What are the mode shapes are I am getting, I will like mention here directly, so it will save our time. 1 minus 1.94, 1.94 is that 1, that 5 2 is that. In this we have normalized with the degree of freedom 1. Okay, and the degree of freedom 1 is this. This is 1, this is 2, this is 3.
In every question, they will mention, right?
That
Normalization.
no, it is not need to be like the normalize. It is that is your choice. There is, if you don't do the normalize, that will also work. So that doesn't affect your answer.
Suppose for phi 1, if I normalize with the df 1, for phi 2, can I
Yes,
normalize
yes, you can do that.
any other one? Okay.
Yes,
No.
you can do, no problem.
Okay.
1, 1.28. We are normalizing for the like the our calculation would become easier. One main thing is that. And other thing is like the normalization, like if you, I don't do the normalization, it will, you will not able to compare it, like if some value is point 0.3, some value is negative point 0.5.
Yes, yes, yes.
So that's how these things work. Okay, so can we draw the mode shapes now?
Here for phi 3 we are getting 0. Uh,
Yes. If you put that, your phi 3 would be become 0. In the one of the case in the last we have seen also, phi 2 was 0.
no, no. Here you are telling DOF as a normalizing. So first DOF is a normalizing, right?
Yes.
Here we are getting 0 means
So
initially we have to assume 1, right, for a DOF.
for the DOF, if you assume 1, like in the third mode, it is not necessary that my that mode is coming to be deformation. So how can I it will 1? It would be the different one. In the
Okay,
if you seen in the last cases, in the second mode we have the 0, -1, 0, 1.
okay,
So that
that,
can be 0.
okay, okay.
So it is not a new thing. So what is this? This is your one direction, this is your two direction, and this is your three direction. So in the one, it is going to the one, like this one, and it is the two, it is going to be negative -1.94. So it is going to be this much, like this much is it is going to be 1.94, this much is it is 1, and that is also 1.94. 1.94. Okay, and that is the one. This is a mod shape for the one, or that will be coming like that, that that way, that will come coming like that. Okay. Similarly, for the second mode, we can draw the mode shape. So in the second mode, like we have the, again that is a one, so that will again here it will be coming out to be one, and then it is a 1.28. It is in the positive side. Okay, so that will be here, something like that. So it is going like this one. Okay, so it will be going like this, and that is the negative side, which is this. So that is 1.28 in the negative, that is 1.28 in the positive, and that is the one in this direction. Now the third mode shape. For the third mode shape, what you have that is 0 in the u1 direction, and 1 1 in the 2 and 3. Like my it will be deflect it here, it will be deflect, it is 1 1. So it will be deflect like this, 1 1, like no deflection in my column. Okay, so these are the three mode shape. Now to find out the response of the free vibration response, you have given the initial condition u is equal to 100. Okay, that is the condition you have given, and that it is not given to you, so that would be the 00. So you can find out the model expansion vector. Qn 0, it will be the phi 1 phi and t m u over phi and t m phi n. So q1 0. So what is my phi 1 t? It would be the 1 minus 1.94, 1.94. Mass matrix, I have the 5m 00 m 00 m, but that is given 100. So that become 1, 1.94, 1.94, 5 m, 0, 0, 0 m, 0, 0, 0 m times that 1 minus 1.94, 1.94. So get me the solution for this Q10, what you are getting. Similarly, Q20, you can do that. For that, we have the mode shift. Let me write it 1, 1.28 minus 1.28. Mass matrix would be similar, 5, 1, 1, that is 100. That would be the 1, 1.28 minus 1.28, 5, 1, 1, 1, 1.28 minus 1.28. So this is also get me to that. And for the Q3, you have the like mode shape is 0, 1, 1, 5, 1, 1. So that is the 100. That would be again 0, 1, 1, 5, 1, 1, and then it is 0, 1, 1. So anyone with the values? Okay, let me write those values. So I am getting this as a 0.396. Okay, I am getting this as a 0.6031, and Q3 is 0. Can you give me the Q1.0, Q2.0, Q3.0? Anyone? What it would be?
0.
It would be 0. So you can write the response ut is equal to summation of n is equal to 1 to 3 phi n qn 0 cos omega n t plus qn dot 0 omega n sin omega n t. Okay, so let me write the solution u1 u2 u3 t t t. So the phi 1 is what? That is 1 minus 1.94, 1.94 q1. So q10 is what? It is the 0.396 cos omega 1t, and here it would be 0 because we don't have this value. That is the 0 initial velocity. So for the second mode, it would be 1, 1.28 minus 1.28 times q20, so that is the 0.6031 into cos omega 2t. Is there anything else would be there? Anyone?
No.
Because my q3 is 0. Okay, so if I simplify this, it is coming out to be 0.39, 0.77, 0.77 cos omega 1t plus 0.60, 0.77 minus 0.77 is that cos omega 2t. So this is my u1t, u2t, u3t. So this is my final answer. Any doubt? Anyone? In all 4 or 5 problems we have solved. So are you facing any doubt? If you have, you can ask here. Anyone? And is there any doubt in the related to the currently week assignments? I think it is very easy. There is nothing new. All things which have discussed, that is the same. Anyone? Do you have doubt? Anyone? Any
So this
suggestion?
kind of lengthy questions will also come in the exams.
Yes, that would become, because there is multi-degree of freedom system you need to solve. So for this you have to, like, the for the finding out the mode shape, those questions would be morely related, not much, because that question is becoming looking you as a lengthy, because we don't have the value of the MEI. Once you will be having the value of the MEI, then it would become like you can solve it in the calculator easily, directly. So at that time procedure would be same. So
Okay, sir.
that you need to follow. Else calculation become easier if you have all the values, not much problem. Anyone else? Any suggestion regarding which thing I need to incorporate in the session, because now we have only 3 session left after this. Anyone? If not, can we conclude the session?
Yes, sir.
Okay, thank you. You can left if you have if you don't have any question, you can leave the meeting.
Sir, in the week 8 solutions,
Yes.
number 1 actually,
Yes.
uh, I had a doubt because of the no the symbol shown for the inertia, no, mass inertia mx double one.
Yes.
Why the no it was shown downwards when the displacement is also downwards? It should be in the opposite direction. I was not able to.
That inertia should be upward, but the solution is right, only the sign
So a
convention
solution
is
is right. It looks like,
maybe
but
some
concept wise, I was having a
okay,
difficulty
okay,
in.
okay, maybe some glitch, like the in the I will ask them to correct it, or either that mx double dot, it would be always higher in that case, in both the mass inertial, so that is not a problem.
Then all the three will be acting opposite to the deflection, huh? Direction of deflection, initial displacement.
Like the
M, C, and K.
uh, we have discussed that thing in the initial part, initial of the
Uh,
lecture. So in the case, if you consider the in this, if you look at here,
uh,
in this case, if you consider your x1 is greater than x2, in the first
hmm.
mass, it all would be the upward.
M, C, K all will be upward.
Yes.
This one, the corresponding coefficients, mx double dot,
Yes.
C
Yes.
x dot,
mx
and
mx.
everything will be upwards.
Yes, that would be upwards.
Hmm. Okay.
Is it okay?
Yeah, yeah. Okay.
So you are getting the answer A and C, because there was in the C there was some typing mistake, that should be x2, not the x1.
Hmm. Okay. But concept wise, it should be because it was shown downward. I was thinking why when x1 is
I
downward,
think
why the inertia force? Yeah.
whoever made this solution, that at that time they have done some mistake.
Okay, okay. No, that is okay. Solution plus or minus is okay, but at least the free body diagram should be not confusing. Actually, I was
Yes,
just
yes,
thinking
yes,
that.
yes, that's why the
Free body
live
diagram.
session.
When you make an assumption itself, you should not get the answer in the negative. Actually,
Yes, yes.
the assumption should be such that we get the result in the positive direction, so that our assumption is right. Actually, yeah,
I will ask them to from the next assignment. They won't do that sometime
yeah, yeah.
because
Okay, sir.
that I don't know how that kind of mistake can be there, but might be due to some human error can be there
Okay, okay.
anytime
No problem.
anywhere. Okay, thank you.
Okay, sir. Thank you.
Okay.
Thanks a lot. Bye.